What does our future hold? Not just for us, but for everything. If we listen closely to the cosmos, we hear a story written in light and cold. A story about how everything began, how it changes, and how it all will end. We begin right now, in this fragile moment we call the present. Cities glow, oceans breathe, and a thin layer of atmosphere protects a species that looks up and asks questions. We've mapped the sky and measured ancient light, but we're still at the very beginning of a very long story. Let's step forward in time. A minute becomes a millennium. History fades into prehistory. In the near future, the Earth we know will shift. Ice will melt and refreeze. Continents will crawl, and the magnetic poles will flip. Our machines will venture out, carrying our curiosity in their metal bones, adding our tiny signatures to the grand story of the sky. But this is just the preface. Fast forward tens of thousands of years. The constellations we know will untie themselves. The North Star will wander off. Our monuments will erode into dust. The Sahara might bloom green for a while, then return to silence. The Earth is restless, always turning, never still. Further ahead, stars we know prepare for their grand finales. Betelgeuse, that ruddy giant, will one day tear itself apart in a supernova, a celestial firework for any future sky. Antares, too, will end in thunder. Across the galaxy, the universe is still in its youth, full of brilliant, catastrophic births and deaths. Now, let's push farther. Tens of millions of years. Continents merge into a new supercontinent, only to break apart again. The moon drifts slowly away, making our days just a tiny bit longer. Species will appear, flourish, and vanish. Life is resilient, but time is relentless. Hundreds of millions of years pass. The sun, like all stars, brightens as it ages. At first, our planet will adjust, but then the balance will tip. The green engine of our world, photosynthesis, will falter and fail. Oceans will steam away. The sky will thin. Earth will become a memory of water, a scar of rock. If our descendants survived, they would have long since moved on, perhaps to cities under the ice of distant moons, or starships sailing between the lights. Time pushes on the sun, approaches its last great change. As its core runs low on fuel, its outer layers will balloon, swelling into a red giant. It may swallow the inner planets, Mercury and Venus, and scorch the surface of Earth. For a while, its light will be deep and red. Then, shedding its brilliance like petals, the sun will shrink into a tiny, hot ember, a white dwarf. The blaze is over. Only the coal remains. This is the common story of stars. Throughout the cosmos, they are born, they live, and they go dark. One by one, the star fields of the night will thin. The age of starlight will end, not with a bang, but with a dimming that takes eons. The universe now enters its elder years. No new stars are born. All that remains is a graveyard of remnants. White dwarfs cooling to black, spinning neutron stars, and silent, invisible black holes. Galaxies will grow thin and ghostly. Gravity, ever patient, will slowly shepherd everything toward the central black holes. Space will keep expanding, pulling distant galaxies beyond our view, sealing their secrets away forever. Beyond the imagination's reach, even matter itself might not be permanent. Some theories suggest that protons, the very bricks of atoms, could eventually decay. If they do, everything we know, rock, iron, diamond, will unwind into a whisper of radiation. If not, gravity will simply continue its slow grind. Either way, the last great actors on the stage are black holes. In this far-flung era, the only major events will be when they collide, sending ripples gravitational waves across the fabric of space-time. If there were ears to hear, they would hear space itself sing. But even black holes are not forever. Thanks to a bizarre quantum effect, they slowly, incredibly slowly evaporate. Over trillions upon trillions of years, they radiate their energy away, shrinking until they vanish in a final, brief flare of light. After the last black hole fades, The universe becomes a place of almost absolute cold and emptiness, just a thin soup of radiation and particles, forever expanding. This is the heat death. Not heat, but the death of difference. The arrow of time, which drives all change, will have nowhere left to go. Time itself will become meaningless, because nothing will ever happen again. But is this the only possible ending? Not necessarily. We don't fully understand the dark energy that's driving expansion. If it gets stronger, it could tear the universe apart in a big rip. If it weakens, gravity could win, pulling everything back into a big crunch, which might even trigger a new Big Bang. So, what does this all mean for us, right now? The timescale is so vast, our minds can barely grasp it. But meaning isn't measured in years. It's measured in attention and care. The universe gives life a brief, bright window to exist. In that window, we can create art, we can feel love, and we can ask these incredible questions. We aren't insignificant because the cosmos is vast. We are significant because we are the part of the cosmos that can understand that vastness. So we return to the present. We know that stars fade, mountains crumble, and even time itself may lose its meaning. Our task is not to stop the tide, but to build something worthwhile while it flows. Long from now, the last light will go out. But here and now, there is light. There are mysteries to chase and futures to build. This journey to the end of time is a map drawn in pencil, and it will change as we learn more. If you want to join us on that journey of discovery, like this video, share it with someone who could use a little wonder, and subscribe. We have a universe to explore, and a brief, beautiful moment to do it together. Thank you for watching.